Good morning, everyone, and welcome to our session. I just learned this morning that this is the 10th year of adaptTo, which is really great, and it's really exciting to be here and have the opportunity to introduce to you our new cloud-native version of AEM called AEM as a cloud service. I guess it's no understatement if I say that this is probably the biggest change around AEM since its invention more than 10 years ago. My name is Alexander Saar, and at Adobe, I am responsible for what we call the AEM Cloud Foundation Engineering. Co-presenting with me today is Carsten. Carsten, do you quickly want to introduce yourself?
Yes, thanks, Alex. Hi, hello, and welcome. My name is Carsten Ziegeler, and I'm Principal Scientist at Adobe. As you probably know, I'm one of the creators of Apache Sling and an architect for the Adobe Experience Manager. And I think it's great to be back at adaptTo, especially this year. And the growth of the conference is amazing, right? It started 10 years ago with a very small venue, and now we have this globally distributed conference, which is really, really amazing. So thanks for all the effort of putting this up, and with that, back to you, Alex.
Thanks, Carsten. So let's get started. Let me start with why we actually built a new version of AEM. The goal was to revolutionize how AEM is being delivered in the cloud, with full agility and for never-seen velocity of innovation for our customers and partners, while retaining all the ability to customize it, extend, and build great experiences with AEM. But why does it have to be cloud-native, you may ask? Well, research shows that the use of cloud-native technologies is predictive for delivery performance and availability. And more specifically, teams that have adopted cloud-native technologies are able to deliver 208 times more frequent code deployments, achieve 106 times faster lead time from commit to deploy, 2,604 times faster time to recover, as well as demonstrate 7 times lower change failure rate. It's these traits, frequent deployments in a safe manner, fast lead times, and a really high availability that we wanted to enable for the AEM community as well. To achieve this, we started out with 3 major design principles that guided all of our thinking and discussions. Number 1, always current, referring to every customer and every deployment always being on the same latest version of AEM and having access to all the latest improvements and innovations. 2, always at scale, meaning that you don't have to worry initially about right-sizing your infrastructure, and your application and system can grow with you as your experiences become successful, and there are no inhibitors to this. 3, always on, referring to a system design that has self-service and self-healing capabilities at the core of its architecture at all layers. Now, when we looked around in the industry, we realized we couldn't really find a lot of examples that could serve as a blueprint for our own transformation. However, we found industry examples that showed that there was a massive change in how value is being delivered over the years. Take a look at the automotive industry, for example. As shown on the picture here on the top left right, which is an Opel workshop from 1911, in the past, every piece of the car was hand-hammered on the workbench and then applied to the immediate car or experience, in our case, next to it. We have seen similar patterns in the experience management industry. It's a very sequential process today, one role after the other, from developer to tester to the business practitioner. To deal with this, we added some automation and standardization. However, we still realize that there is a lot of fragmentation across all the various deployments of AEM. The graph here at the bottom shows this. It's a mapping of major work types that occur throughout the project for multiple of our customers. And as you can see, there is a lot of variation in this, becoming an inhibitor to repeat success and move fast. For the AEM cloud service, we envisioned a picture like on the right side, a fully cloud-native service with full automation and self-service, based on shared services across all our customers and deployments, while still keeping the ability to customize, extend it, and build great applications on top of it. Now, what does this mean for us as developers, and why should we care? If we look at a typical enterprise project, then following the initial implementation and go live, there are typically a lot of activities just to keep the application and service going, from regular maintenance releases that need to be deployed and validated to full product upgrades, typically every other year, which usually result in a full multi-month project. With the AEM cloud service, you don't have to worry about this anymore. Your application and services are updated by Adobe multiple times per week in a very incremental and safe manner, without downtime or any business interruption. For us as developers, this in the end means we have more freedom and more time for innovation and build great experiences and value for our customers. And isn't that what we all would prefer? Now, I realize for many of the experienced AEM practitioners out there, this may sound like science fiction. So let's do a quick reality check. 8 months ago, we released the first version of the AEM cloud service. Since then, we are running more than 1,000 deployments on the platform. To all of these deployments, we have shipped today 97 releases containing more than 16,000 changes and improvements and new innovations. Think about what this means in the old model. In the old world, all these changes wouldn't even have been released yet, but only at our summit next year. And even then, once released, they wouldn't be available right away to business practitioners. But you have to go through an upgrade project first, as we have seen before. So that's a quite long lead time for all these improvements to actually reach our partners and customers and create the value that we expect from them. Now, when you start such a change, there are usually typical different paths that you can approach such a transformation. One very obvious way, usually preferred by many engineering teams, is to just start from scratch, greenfield, and come up with an entirely new service. However, we did not really consider this an option for us, since we realized the massive investment the entire ecosystem has made into AEM over the years. So we really wanted to find a way to retain that investment. So we started out years ago already on what we would call a revolutionary evolution, meaning that over multiple years, we have looked very closely at the monolith that AEM was and tried to figure out how we can move that gradually into a completely new setup based on cloud-native technologies. Starting in 2017 with what we call the separation of content and apps, which really allowed us to manage content and application code in different life cycles, which opened up new possibilities for us to deploy without disruption. Later then in 2018, we started to introduce 12-factor principles and also added containerization, looking at the entire stack, including Java, and figuring out how to run that safely and smoothly in the containerized world. In 2019, we started to look at multiple services within AEM and identified various services that we carved out and moved to a separate setup so that they can really benefit from cloud-native technologies and scale accordingly. Carsten will tell you a little bit more later in this talk about this. In addition, we built a control system around AEM, which allowed us to realize self-service capabilities and full automation. All of this work ended up early in 2020 with the general availability of the first version of the AEM cloud service. But of course, we are not done here yet. Going forward, we will add additional capabilities that are not available in the AEM cloud service as of today. For example, AEM forms or screens. We will also continue to look at the core of AEM and identify additional services that will benefit from more cloud-native technologies, and will continue to carve them out and move them into separate setups. And with that, let me hand it over to Carsten to give you a better view into the architectural changes that we made in order to make this happen. Carsten, take it away.
Thanks, Alex. We will now look into the software stack, the architecture of our cloud service, and our CI/CD process. But let me start with repeating that at the core, we still have our good old friend AEM, despite all the revolutions, innovations happening to AEM over the past years. The foundation is written in Java, powered by OSGI as a modular system. And actually, with that choice, over a decade ago, we made a statement for modularity, allowing us to better control the separation of API from implementation, managing the evolution of the API in a compatible way, as well as separating customer code from product code. While we probably didn't think about it in the beginning, during our journey, it turned out that modularity is also key for evolving AEM into a cloud service. Modularity is relevant, especially for splitting out functionality into separate services in a very efficient but also transparent way. And of course, the core of AEM as a cloud service is built on top of all those great open source projects that we all love, like Apache, Jackrabbit, Oak for the repository, Apache Felix for the OSGI implementations, and Sling, of course, for the application framework. So existing customer projects, all the code, the patterns, they just continue to work in AEM as a cloud service. For the majority of the code, no changes are required. There might be some cases where code based on patterns of a static on-prem deployment does not match a cloud-native approach. An example for that is disruption, which is happening in the cloud more oftenly, especially with the frequent updates to the application. While on-prem developers usually live a false dream of applications running forever, this illusion is gone in the cloud. Background threads might stop at any time. But clearly, disruption is nothing new for AEM in the cloud. It's just more prominent in this scenario. So code needs to be resilient. And for example, it could just use Sling jobs with its at least once guarantee. But in general, to help our customers identifying and adjusting such code, we provide quality gates, checking that code for known anti-patterns, bad API usage, and so on. But in summary, all that you know about Apache Sling, Oak, Felix, OSGI, AEM is still valid and can be used continuously. While we cover the high-level picture of AEM in this session, you will probably hear more details in the upcoming talks throughout the next days. So the software stack is the AEM that we all love. Let's have a look at the architecture. At the core of the architecture, we have the two main tiers, the publish and the author tier. This is the AEM setup you know for years. It has been proven over time, and we continue to build on top of that, of course. As we will see in the next slides, each tier has different scaling requirements, but both tiers have a fully fledged AEM running. The most important aspect of AEM as a cloud service is security and protecting customer data. Therefore, we've built an architecture where customer services are completely isolated from each other. So that includes isolation of data, compute, network. In the past, maintenance jobs like repository compaction were running in process, consuming resources like I/O, CPU, memory, which was taking away from the normal processing and had potentially a negative impact on the experience. We removed that impact and split out those periodically running maintenance jobs into separate jobs, which are running independent from the author and the publish tier. And therefore, we remove the negative impact or the potential negative impact. For the per customer AEM services, we make use of the previously mentioned separation of code and content, and the composite node store from Apache Oak allows the split. So the code, namely everything that is stored in /libs and apps, is directly stored in each instance. The mutable content is stored in the content repository service, again, protecting customer data as the highest priority. There's a separate node store for author, there's a separate node store for publish, but a shared blob store for the binaries. And of course, these stores are isolated from each other. Click, please. Following this pattern, we started to split out more functionality into separate independent services, like identity management, replication, CDN service, or the assets compute service. And we will look at those on the next slides. And we continue to that same pattern to quickly develop and integrate new services, like the testing service, for example, which integrates Google's Lighthouse, measuring the quality of your website. But let's look a little bit deeper into the different services and start with the author tier. For authoring, high availability and enterprise scale, supporting hundreds, if not thousands of authors is important. Therefore, the author is set up as a cluster out of the box. Each AEM author instance connects to the same stores in the content repository. And this setup ensures a high consistency, but also allows to scale based on needs. It scales horizontally based on demand, up with increased load, down with reduced load. Independent from the author tier, the content repository service can scale based on the author requests. And that together, the two different tiers scaling differently ensures the enterprise scale that we need for authors. And of course, downtime for an author is not an option. On the other hand, we have these frequent product and application updates on a daily basis, basically. And the separation of code and content is making each instance self-sufficient, of course, with respect to code. But it also allows to perform rolling updates. While the existing instances are still running, new instances are spin up with a new code, and they start to connect to the shared content repository. And once all of the new services are running, the old ones are basically stopped. And due to these rolling updates, there's no downtime of the author, and there are no interruptions. Click, please. I mentioned earlier on that we have additional services as part of our cloud. And for example, the author tier is out of the box connected to the identity management system, which on the one hand allows enterprises to connect to their identity management providers they want to. On the other hand, this makes AEM a first-class citizen in the Adobe clouds. For example, other solutions like analytics from the Experience Cloud can be seamlessly integrated. Let's have a look at the next service we have, the publish tier. The publish tier is even more critical to our customers. While we need this enterprise scale for authors, we need a much higher scale for the publish tier to support millions, if not billions of users. And downtime, again, is simply not an option. Therefore, the architecture of the publish tier is using a farm approach. Unlike the author tier, where every instance connects to the same repository, each publish instance is self-sufficient, code and content-wise, ensuring highest availability of the website. Publish instances always need to be up to date with regards to the published content. Again, the publish farm scales horizontally based on load. New instances are started frequently, and of course, they need to be up to date with the content. The old replication mechanism we used in AEM with the point-to-point connection between authors and published instances does not meet these requirements in the cloud. Therefore, we implemented a publish-subscribed-based messaging pipeline for replication. An author publishes content by sending a message to that pipeline, and that message is received by all published instances. As a blob store is shared between authors and publishers, only the content is replicated through that pipeline. Click, please. The messaging pipeline ensures that all publishers are up to date. For having new instances up to date quickly and automatically, a new dedicated publish instance called the Golden Master is added to the publish tier. The Golden Master is not serving any requests, but it receives the messages from the messaging pipeline and stores the updated content it receives through that pipeline in a blob store. Now, when new instances start, due to scaling or due to code update, they pick up that content from the blob store first, and then pick up all newer activation messages which might have been arrived in the pipeline. And with that mechanism, new publishers are up and running with latest content very quickly and efficiently. In addition, the Golden Master performs the usual maintenance tasks like compaction, not affecting the publishers anymore. But of course, the replication service is still programmable using the existing replication API. But we didn't stop here when it comes to publishing. Next slide, please. One of the benefits of moving AEM to a cloud-native service being operated end-to-end for our customers is that we can better leverage existing cloud service and build a service in a way that allows us to provide maximum value. AEM experiences are created by a few, delivered to millions of customers. Therefore, we continue the split of author and publisher, as mentioned. On top, the delivery architecture optimizes the content distribution by default to scale globally and minimize latency. AEM as a cloud service comes with an integrated Edge CDN configured and optimized by default. This means content is delivered to our customers directly from local CDN endpoints, which ensures a consistent experience around the globe. While customers may choose to continue using and integrating their existing CDN vendor, the out-of-the-box capabilities already cover the majority of use cases. Click, please. We are also working on a standardized and automated way to deliver geo-distributed publish farms. These are updated with content activation messages over publish-subscribe messaging layer, capable of delivering millions of messages at sub-second latency. Traffic is routed from the edge to origin, leveraging DNS to ensure that the global edge points always route to the most appropriate publish farmer. But let's look at more capabilities we have in AEM as a cloud service. Another example is the asset transfer and processing in AEM as a cloud service. In the past, assets were uploaded directly to the AEM author, and with this were limited by the network capabilities and processing power of the authors. It was possible to scale this vertically with more powerful VMs or horizontally through increasing the author cluster. But depending on the type of asset, the processing could take significant resources away from the important request processing. That's why we introduced the Assets Compute service. With this service, click please, the client requests from the author a temporary signed URL. And next, the client then uses this URL to upload the assets directly to the blob store, leveraging local CDN endpoints for fast transfer from the client. Parallel uploads of assets is also supported. And then next, once the asset is available in the blob store, AEM will send a processing request to a set of processors implemented as functions on top of Adobe's I/O runtime using a serverless approach. And these processors will take care of extracting metadata, full text extraction, generating thumbnails, generating all the renditions, and so on. And then at the final step, they are made available back to AEM. Click, please. Right. We were able to do this without any changes to AEM and the user experience, but still we removed all the scaling limitations and complexity, now providing a solution that scales orders of magnitude better than before. Similar to the upload-download requests of a binary are not served by AEM directly anymore. A request to such a binary is redirected to the CDN-fronted blob store. And that serves two purposes in the end. On one end, it frees AEM from streaming the binary, but it also allows clients to download these binaries from closer endpoints, resulting in a faster experience. Remember that in the beginning, I mentioned that existing code should be updated to new patterns where appropriate. And here we have a good example for that, the direct asset upload. If you have developed your own UI or a tool to upload assets, it will still work out of the box. But without changes, the binary will still go through AEM with all the drawbacks mentioned. So it's highly recommended that you adjust your code to this direct upload protocol, which usually is just a small change in the front-end code. But of course, the benefits are immense. The direct download, on the other hand, is transparent, so you don't need to change your code to use that. So the Asset Compute Service is another great example how cloud-native architecture allows us to integrate new functionality much easier and more efficient, providing new value to our customers much faster. For example, we could just provide additional value by leveraging Adobe Photoshop, bringing all of our great, powerful image technology seamlessly to AEM. So with that, let's get to the final piece, which is actually my favorite topic, our CI/CD system, which should give you an impression of how much effort we put into this process for not breaking our customers when we do update. Now, we had this traditional development process with this yearly release cycle with a code freeze at the end, extended testing phase, manual testing, and all that stuff. But for cloud service, we needed to have a system that supports the always-on principle so that we can ship new functionality fixes as soon as possible. So how did we do that? At first, you could think that you do a staged plan where you're just shortening the release cycle, so 6 months, 3 months, 1 month, and so on. But that in the end leads you to making wrong decisions during that process. Therefore, we did the whole step in one step, basically, without doing any intermediate steps, and that allowed us to have the right design from the start. So we implemented a fully automated system, allowing for frequent and safe updates. And each component, like asset sites, has its own CI/CD pipeline running an extensive test suite for each of them. Our engineers check in regularly, many times per day, and then that component by itself gets updated. Click, please. So on a daily basis, we have dozens, sometimes hundreds of such pull requests across the whole product. And triggering by a change to the component, we assemble a full deployment of the system and validate this with a comprehensive test suite based on a reference site. At this stage, we basically know that the standard system is working as expected. And then we create an internal release. Click, please. In the next stage, we validate each new release with a set of customers where we basically clone their environments and run our entire test suite of tests, as well as customer-provided tests. So we have a comprehensive validation, including customizations. In fact, we use more data points, including machine learning and other processing tools to validate the final release. Click, please. And only if we have a very high confidence that we did not introduce any issues, we make the release public and initiate the rollout to customer systems. And as mentioned, those systems are then updated in a rolling fashion without downtime. And with this, we conclude the run-through of the high-level architecture of AEM and how we build and operate this. Now back to you, Alex. Wrap it up.
Thanks, Carsten. So as we have seen, AEM as a cloud service presents a really big milestone in AEM's evolution, taking it into the cloud-native world. Based on our 3 design principles, always current, always at scale, and always on, apologies. It provides the basis for scale and innovation for the years to come. And with that, I guess we have time for a few questions. Okay, Carsten, do you see any questions already? Okay.
I don't see any questions yet.
Okay, I see the first one here by Sven. Does the asset microservice also include features like asset optimization processors? For example, make and provided asset ready for the web. And I think, yes, the answer to that is yes, it does. AEM had some capabilities here already in the past. The asset processing service will only expand on that. So everything you know before will already be there. Like Carsten explained, there will be new capabilities coming as well. And many came already with Photoshop and other technologies. To be honest, I don't know from the top of my head what all was added here in detail, but surely we can connect later on this throughout the conference. Worth calling out that also the asset processing service is extensible. So if you have some custom requirements here, then of course you can still build, like you have been used to with AEM, build your own capabilities into the service based on the serverless platform that is being used there. All right, next one. How do you handle deprecation of APIs? Carsten, do you want to take that one?
Right, sure. So basically what we do, we mark that API as deprecated using the normal Java mechanism, and then we monitor usage of our customers. And this process basically means that we plan to remove deprecated API like after three months after deprecating them, if no customer is using them, right? I hope that makes sense, what I'm saying.
Yeah. And of course, with the service, we have the means to, so we know our customers very well running on that service. We have the respective channels in place. So if we see users that are still depending on this API, this gives us the ability to reach out and get in touch with them and work with them to get to the respective alternatives. So compared to an on-prem world, that's really a much more powerful tool for us to make sure that we can evolve the system efficiently. Okay, so there's a lot more questions coming in. I know we are at the end of the time, but we have we are fortunate enough that the break is right after our session, so we can stay a little bit longer if you want to stay around and try to answer as much as we can. Okay. So is that 1,000 customers of or environments that include things like sandboxes, etc.? Yes, so the 1,000 environments are 1,000 full AEM environments. So that includes customers, but that also includes developer sandboxes, setups for multi-month POCs, etc., etc. It does not include, however, all the systems that we run internally for our own engineering teams to develop the service. So these are really just the environments that are running on the production environment. Okay, so next one is how do you provide a fast CDN solution for the Chinese market? We don't have the full answer to that yet, so that's an active topic that we are looking into. So apologies, we will be providing an answer for this at the right time, but so far we haven't concluded on the discussion here yet. Okay, so next one. When AEM as a cloud service first launched, there were only a handful of Azure regions. Oh, it's moving here in the chat. Where was it? Oh, it moved up there. Where it was available. Have any other regions launched since then? Yes, a couple of additional regions have launched within Europe, but also US on the West Coast, and we will continue to add new regions. However, the dependency on specific regions with the AEM cloud service should start to reduce compared to managed services or the on-prem world before. As Carsten illustrated, for delivery, we have a CDN, and we are that helps us to scale globally. We also have we also use the CDN for things like, for example, for uploading assets. So that really helps us to scale globally without having the actually core AEM service locally and nearby. We recognize, of course, that there's other requirements than just scale from regulated industries, GDPR, etc., etc. So we take all of this into account as we continue to add new regions and roll things out globally. Okay.
So maybe, Alex, we can take the other questions to the panel, which we have later on. Or I guess there's an offline variant to answer questions as well.
Yeah. I think we should start to clear the room. We are also around here for the whole conference. So through the app, you can get directly in touch with us, and happy to have any meetings or side discussions in the lobby or elsewhere to answer any questions you may have or any feedback you want to give us. So thanks everyone for attending. It was really great to have this opportunity. A lot of great questions. So I'll make sure we capture all of those for sure. And yeah, try to answer as much as we can throughout these 3 days. Thanks everyone.
Thank you.